Welcome back. Doing Advent of Code here, day 6. We just finished day 5, and so let's take a look at the next problem. You've landed at the Universal Orbit Map facility on Mercury. Because navigation in space often involves transferring between orbits, the orbit maps here are useful for finding efficient routes between, for example, you and Santa. You download a map of the local orbits, your puzzle input, except for the universal center of mass. Every object in space is in orbit around exactly one other object. An orbit looks roughly like this. In this diagram, the object BBB is in orbit around AAA. The path that BBB takes around AAA, drawn with lines, is only partially shown. In the map data, the orbital relationship is written AAA BBB, which means B is in orbit around A. Before you use your map data to plot a course, you need to make sure it wasn't corrupted during the download. To verify maps, the Universal Orbit Map Facility uses orbit count checksums, the total number of direct orbits, like the one above, and indirect orbits. When A orbits B and B orbits C, A indirectly orbits C. This chain can be any number of objects long. If A orbits B, B orbits C, and C orbits D, then A indirectly orbits D. For example, suppose you have the following map. Okay, I can turn it into a tree. Fun. That's a hint. In this visual representation, when two objects are connected by a line, the one on the right directly orbits the one on the left. Here, we can count the total number of orbits as follows. D directly orbits C, and C, and indirectly orbits B and COM. Total of 3 orbits. L directly orbits K, and indirectly orbits J, E, D, C, B, and COM. Total of 7 orbits. COM orbits nothing. Okay. That's an interesting one. So we're doing day 6, part 1. That's day 5, part 1. Cool. I didn't break it. Download 6. Puzzle 2019. 2019 input. Let's get our puzzle input here. They are all 3-digit codes. So that's any particular consequence, but okay. So question is, how do we want to build up this structure? We're going to build it up in a tree and traverse it to figure out these, or is there an easier way? Easier way. I mean, I kind of want to just stick them all in a hash. It's the reason I can't do that. Let's try to do it and see what happens. All right, so we're going to go input dot each to, and it's going to be an orbit, and we're going to say, so what was the syntax again? So we say B orbits A. So can do like center. I'm sure there's actually words for these, but this is what we're getting. Split on this, and orbits. And we're supposed to interact orbits. So we probably want to say we want to be able to look up a thing by what it orbits. So no, we want to be able to look up a thing and see what it orbits. So that, and see how close that gets us. Orbits is going to be a gigantic hash. Cool. Looks reasonable. Orbits com. So that's what I expected. Can you invert a hash? Yeah, okay, cool. So the number of direct orbits is just, so we need the direct orbits, and direct orbits is orbits.keys.count, or I think you can just call count on a hash. So that's that. And indirect orbits is the trickier one. And so every key is something orbiting something else. So we should be able to iterate through them, figuring out how many orbits the thing has. I'm sure you can do this by constructing a tree and storing storing the distances or whatever. There's a thing you can do, but I don't think we need to do it. So let's try. Maybe it's a little recursion or something. We might have to cache the values though, which would just make it so doing it the other way would be faster. But such is life. Or we can count the orbits of a moon by and there's going to be orbits.keys.sum. I guess these are supposed to be planets, but we're going to refer to them as moons because they're orbiting something. And it's orbit count moon. And we'll call this orbit count. And inside of here, we'll say if I can do this, because I can get the moon and the the center. Terrible naming. So we had a physicist in chat to yell at me for what I'm supposed to call these. So we don't care about the actual one, so we can do that. So if moon equals com, we want to return 0, I think. And otherwise, we return 1 plus, sorry, I don't need to explicitly return 1 plus orbit count of at orbit moon. That could conceivably work. Correct for nil class. Yeah, that's nil. Sure, that's a number. Maybe it's the right number. Boom, easy. Didn't even have to do the hard stuff. 2019, part day 6, part 1. No tree traversal required. Let's see what part 2 makes us do though. Now you need to figure out how many orbital transfers you need to take to get to Santa. You start at the object you are orbiting. Your destination is the object SAN is orbiting. An orbital transfer lets you move from any object to an object orbiting or orbited by that object. Okay, that's sounding a lot more like the graph. For example, you have the following map. Visually, you can do that, and then you want to know how you can get to Santa. This example, you are in orbit around, yes, I understand the example. After the moon, 4 orbital transfers is required. So you transfer to J, E, D, then I. J, E, D, I, and you spell Jedi. Very cute. What is the minimum number of orbital transfers required to move from the object you are orbiting to the object SAN is orbiting? Between the objects that they are orbiting, not between you and SAN. Okay, that is trickier. That is definitely trickier. Oh man, Roxy's snoozing. Okay. Move that into the initializer because that's the initial setup. For this one, we're going to say let's at least get our source and our destination. So I'm also going to say at super and then inverse. We know we can't invert this hash, can we? Because the values. Interesting. We might actually want to build the graph. Do we know, like, the graph is, or it's a tree, which means we can just step towards the root. Oh, we can just take all the nodes and step towards the root. remove the ones we have in common, and the length of that is the minimum number of steps, right? Surely that's got to be true. Okay, well that's easier. That's not hard. So we want to go from at orbits U to our destination at orbits SAN. Oh, dest. And we can introduce a method that computes the steps to COM, which is a terrible name, from a given moon. And steps is an empty array. Or maybe it contains moon, whatever. Current equals moon, while current does not equal COM. We will I will say we will shovel. Oh, we will shovel current into steps, and then say current equals orbits current. And that seems like a thing that might conceivably work. And then we just do steps to COM source minus steps to COM destination, and take the length of it. That could work. 209, that's a long ways. But answer is too low. Oh, okay. Let's take a look at these values. Too low. Wow. So steps to COM source. It's like eventually. Oh, but it could have to go through COM, right? It's conceivable. No, didn't change the value. Inconsequential, but what? COM source, and it ends in COM, and I would expect them to converge eventually, at least at some point, right? So such COM source. Length. Which means that steps. Source minus steps to best. Finishes at QQS. So one would expect that everything after QQS. Oh, I have to find it in here. Too long. There it is. QQS 70p C9N. QQS 78p C9N. It shouldn't be this far back. I mean, this is what I expect to see. From some point, their paths converge. Oh, I missed the spot. $78p. Oh, is it +1 because I'm missing the actual one where they converge on? That's funny. That's funny. So oh, still too low. What if I wrote it differently? I add them together. That's all of them. And I do a group by identity. And then I were to select only the values where x.second.length equals 1. Oh, right. So this will just be y. My mistake. Length 334. I don't immediately know why that is a different number. but could be the right one. There we go. So instead, I actually counted the unique steps that weren't shared, and that got me the right answer. So neat. Yeah, okay, cool. I don't fully understand why my other solution didn't work, but maybe I need to visualize it. 2019, day 6, part 2. Boom. And, well, I'm going to take a stab at day 7 just because I'd like to. Be right back.